In this video we will be looking at systems of equations. We'll have two essential questions. What is a system of equations and how can a system be related graphically? Definition. System of equations. A system is two or more equations with related variables. A system can be many equations, but for us in Algebra 1 we will just look at two equation systems. So for us, a system of equations is two equations. What we will be seeking is the solution. Solution of the system. Solution of the system. Well, much like our previous definition, a solution is a value that makes the statement true. Well, here we're talking about two equations, so we have two statements. The solution of the system is the value that makes both statements true. The solution to a system is an intersection of two lines. The solution is an intersection. In this video we'll be looking at the graphic representation of a system, so therefore our solution is going to be an intersection. Alright. What are the three ways a system can be related? So now we want to look at the three ways that two lines can be related graphically. Alright, the most common scenario we're going to have is one solution. So, drawing a x and y axis. We can have two lines. And as long as these two lines do not have equal slopes, then they're going to intersect each other at some place. This point of intersection is the solution. Intersection. Alright. there are an infinite number of points on this line, there are an infinite number of points on this line, but this one magical point right here is the single point in the whole world that they have in common. This point is the solution to the system. It's a point of intersection. Okay. Well, occasionally we will have a situation where we have no solutions. Well, one solution is one intersection, so hopefully you can draw the conclusion that no solutions will be no intersections. So, two lines that have no intersections, that's right, they're parallel. So, we have our first line, and then I'm going to come parallel to that and draw a second line. Those lines appear to be parallel. They will never intersect, so there's no solution. Parallel lines have no intersection, therefore they would be a system with no solution. Lastly, we can have infinitely many solutions. Infinitely many solutions. So, hopefully you're thinking now, well, infinitely many solutions is going to imply infinitely many intersections. How can we have two lines that have infinitely many points of intersection? Well, that's right. It would be two lines that are right on top of each other. So, here I draw my X and Y axis again. Here is our first line. And then I draw a second line that is right directly on top of that first line. So in this case, the yellow highlighted line and the red line are right on top of each other. They have infinitely many points of intersection. So, two lines that coincide, like coincidence, co is together, incidence is occur. These two lines occur together, happen together. Two lines that coincide have infinitely many points of intersection, therefore infinitely many solutions. All right, so once more in summary, a system of equations is two or more equations. For us, it would be specifically two equations. What we seek is the solution. Well, a solution is a value that makes a statement true, so the solution of a system is a value that makes both statements true. The solution is an intersection. The solution is an intersection. We have three ways that our system can be related, our two equations. Most commonly, there will be one intersection, and we will seek that point of intersection. Occasionally will be parallel lines, therefore no solution. This is no points of intersection. And every once in a while they will actually be two lines right on top of each other. When two lines coincide, they have infinitely many points of intersections, therefore infinitely many solutions.